In MySQL, transaction isolation levels define the degree to which transactions are isolated from each other in a database. They control how and when the changes made by one transaction become visible to other transactions. There are 4 main isolation levels in MySQL, each balancing trade-offs between performance and data consistency. These isolation levels are defined by the SQL standard and implemented by MySQL using its InnoDB storage engine. 1. Read Uncommitted, description, the lowest isolation level. At this level, transactions can see changes made by other transactions, even if those changes haven't been committed yet, known as dirty reads. Dirty reads. A transaction can see uncommitted changes made by another transaction, which may be rolled back later, leading to inconsistency. Performance provides the highest level of concurrency, but can lead to very unreliable data. Use case, rarely used due to the risk of seeing inconsistent data. 2. Read committed. Description. This isolation level ensures that a transaction only sees changes that have been committed by other transactions. Uncommitted changes from other transactions are not visible. Issues. Non-repeatable reads. A transaction might read the same data twice, but get different results if another transaction commits changes between those reads. Avoids dirty reads, but allows non-repeatable reads. Use case. Common in environments where consistency is important, but performance is still a concern, such as many OLTP online transaction processing systems. 3. Repeatable read. MySQL's default. Description. This level ensures that if a transaction reads a row, subsequent reads of the same row will return the same data, even if other transactions modify the row and commit their changes. This prevents non-repeatable reads. Issues. Phantom reads. While non-repeatable reads are prevented, phantom reads can occur. A phantom read happens when a transaction reads a set of rows that match a condition, and another transaction inserts new rows that match the same condition before the first transaction completes. Use case. This is MySQL's default isolation level and strikes a balance between consistency and performance. Useful in systems where ensuring repeatability of reads during a transaction is critical. 4. Serializable. Description. The highest isolation level. It prevents phantom reads by ensuring that transactions are executed in a way that they appear to be serial, meaning one transaction fully completes before the next starts. It achieves this by locking the tables involved. Issues. Performance. Serializable transactions require more locking, which can significantly reduce concurrency, leading to slower performance. Prevents dirty reads, non-repeatable reads, and phantom reads. Use case. Used when absolute consistency is required, such as in systems that process financial transactions, where even a small inconsistency is unacceptable. Summary of isolation levels and issues. Isolation level, dirty reads, non-repeatable reads, phantom reads.